Derivatives of inverse trig functions are available in your formula booklet. And what I plan to do here is to apply those derivatives in finding other derivatives that will be given. But before I do that, I'll go through some examples on how to find these derivatives. For example, number one, we have y is equal to r cos x, and you're required to show that the derivative of this inverse trig function is equal to what's given here. Well, because this is an inverse trig function, we can write it this way. We can write it as cos y is equal to x, and then we can differentiate it implicitly. Okay, now remember when you differentiate cos y, this will be, we'll apply chain rule. So um, derivative of cosine is negative sine. That will be outside. Inside, derivative of y is dy over dx. So basically, the resulting derivative will be negative sine y dy over dx, which will be equal to 1. And therefore, dy over dx will be equal to negative 1 over sine y. All right, but from the Pythagorean trig identity, we know that sine y squared plus cosine y squared is equals to 1. This implies that um, sine y will be equal to the square root of 1 minus cos y squared. So, but we know that from here, we know that cos y is equals to x, so that means that sine y will be equal to the square root of 1 minus x squared. And then if we plug this result into this derivative, we'll have dy over dx being equal to negative 1 over, and in place of sine y, we'll write this expression 1 minus x squared. And that's the result that you have here. Okay, in number two, we are required to show that the derivative of arctan x is equals to 1 over 1 plus x squared. And just like what we did previously, we can write it such that we have tan y is equal to x. And then we can differentiate that implicitly. So derivative of tan y should be equal to derivative of x. Now, derivative of tan y is secant of y squared. That is outside. And then derivative of y is dy over dx by applying chain rule again. And that will be equal to 1. So dy over dx will be equal to 1 over secant of y squared. But from the trig identities that we discussed previously, we know that secant of y squared is equals to 1 plus tan y squared. And because we know that tan y is equal to x, this is same as 1 plus x squared. So which implies that dy over dx will be equal to 1 over 1 plus x squared. And that's what we have here. All right, so we can apply derivatives that you're given in the formula booklet to find derivative of functions like these ones here. So note from the formula booklet, we know that derivative of arcsine x is equal to 1 over square root of 1 minus x squared. So what we plan to do is to use this derivative um, to find the derivative of this function. So here, remember, we have a function inside another function. So basically, if you consider what we have here, our x here is 3x. So basically, that's our 3x. So which implies that because you have a function inside another function, we shall apply chain rule. And so by chain rule, so apply chain rule. Dy over dx will be equal to, so if we start by inside, derivative of 3x will just be 3, and then the derivative of outside, because our x is 3x, and we know that the derivative of x and x is 1 over square root of 1 minus x squared, we'll just replace x with 3x. So we'll end up with the square root of 1 minus 3x squared. And this will be equal to just 3 over square root of 1 minus 9x squared. The function that's given here is a product of two functions. So basically, because it's a product of two functions, to find its derivative, we need to apply product rule. So apply product rule. Um, which implies that dy over dx will be equal to 4x squared plus 1 multiplied by the derivative of arc tan 2x plus arc tan 2x multiplied by the derivative of 4x squared plus 1. Now, from our previous discussions, we realized that the derivative of arc tan x is 1 over 1 plus x squared. And what we'll do here is to apply that in finding derivative of arc tan 2x. Now, arc tan 2x, we basically have a function inside another function, which implies that when we differentiate that, um, we will be required to apply chain rule. So basically, for the first term here, we shall end up with 4x squared plus 1 multiplied by, now we know that the derivative of arc tan x is 1 over x squared, but our x in this case happens to be 2x. So that will basically be 2x. So we replace the x in this derivative with 2x. So that will be equal to 1 over 1 plus 2x squared. So that's outside, and then inside, derivative of 2x is 2. Yeah, and then for the other part, we'll have arc tan 2x multiplied by, now here, um, let me just use a bracket. So here, the derivative of 4x squared will just be 8x. And then we can put the results together. So in this case, we'll have 2 multiplied by 4x squared plus 1 over 1 plus 4x squared plus arc tan 2x. Well, we have 8x, so we can have 8x in front. So 8x multiplied by arc tan 2x. Now, these two cancel. So we'll have 2 plus 8x arc tan 2x as our solution.